Today we're going to compare two problems. They're inequalities, and we're going to solve them. They're very similar, but there's one important difference. Hopefully you can see what it is. The one I'm solving now has a positive 3x, and when I divide that, I get an answer that is not going to do anything to those inequality signs. There's nothing in it. Nothing's going to flip. Nothing's going to change because I'm dividing by positive 3 here. And when I get my solution set, it says x is less than 2. So I'm going to write down, I'm going to put a 2 here. I'm going to put an open circle, and I'm going to go to the left to include any numbers that are less than but not equal to 2. So solutions in this inequality, numbers that will make this inequality true are numbers like 0, 1, -1, -3. Because if I plug those in for x, for instance 0, if I plug that back into my original equation or inequality, I'm going to get true responses. That's true. So that's true of any of these numbers I picked. In fact, it's true of any number in that shaded region, all the numbers left of 2, not including 2. So let's compare this simple inequality to another inequality to the right here. This one has a -3 in front, and we're going to get very different answers, even though the process that we solve this with is the same. So we get -3x less than 6. Looks very similar, right? 3x is less than 6, -3x is less than 6. But now we're going to divide by a negative. And what we do when we divide by a negative, we have to flip the sign. X is going to be greater than -2. And you'll really see that when you see the number line, because the number line is now going to go the other direction. And our solution set are all the numbers represented by x that are greater than -2. That means to the right. So numbers like, for instance, -1 would be good. 0 as well. 1, 10. All those numbers will work because when you put them back into the original, -3, for instance, 2, -3. So we replace the number by that. Is it less than 3? I'm putting 2 as a solution. Let's just kind of do this up here. Actually, I'm going to do this down here. That's going to be -6 minus 3 is less than 3. -9, is it less than 3? Of course it is. So it is a solution, as we predicted. Anything that we pick under this shaded area and put back into our original inequality will turn out to be, when evaluated, will turn out to be a true statement, and that's why we call it a solution. So this is a good comparison, a good way to understand that once we get to the last step of our problem and have to divide or multiply a number to solve for x, we want to look at whether it's positive or negative. If it's positive, nothing changes. Our sign does not flip. When it's negative, the sign flips, and that's an extremely important thing to know about solving inequalities, and that's why it's different than solving equations. Everything else is pretty much the same. You solve inequalities and solve equations in almost identical ways. You're adding numbers on both sides, you're distributing, you're dividing. All those things happen in solving equations as well as inequalities, but in this particular situation with a negative here, when we divide by a negative, you're going to have to flip the signs. All right, I hope this helps.